The Mystery of the Tiny Sphere, written by Neil deGrasse Tyson. Have you ever paused to admire a raindrop clinging to a leaf? It's a simple, everyday occurrence, yet it holds a world of wonder within it. Or watched a dewdrop glisten in the morning sun? These moments, often overlooked, are tiny marvels of nature. These tiny spheres of water, so commonplace in our world, hold a fascinating secret within their simple shape. They are not just drops of water, they are miniature worlds governed by the laws of physics. The answer lies in a captivating force known as surface tension. This force is what gives water droplets their spherical shape, creating a delicate balance that holds the water together. Imagine an invisible skin holding the water together. This skin is created by the cohesive forces between water molecules, pulling them inward, and creating a surface that resists external force. That's surface tension at work. It's a phenomenon that can be observed in many everyday situations, from the way water beads up on a waxed car, to the way insects can walk on water. It's this force that makes water droplets behave in such curious and beautiful ways. The interplay of forces at the molecular level creates a dance of droplets that is both mesmerizing and scientifically intriguing. But why is surface tension so important? It's not just a scientific curiosity, it has practical implications in our daily lives and in various scientific fields. What makes it so powerful in shaping these miniature globes of water? The secret lies in the molecular interactions that create a cohesive force strong enough to hold the droplet together. To unravel this mystery, we must journey into the very heart of a water droplet, into the microscopic world of molecules. Here, we can see how each molecule plays a role in creating the surface tension that shapes the droplet. Prepare yourself, for we are about to explore a universe contained within a single drop. This journey will reveal the intricate and beautiful science that governs the tiny spheres of water we see every day. A universe within a drop, the dance of water molecules. Within every droplet of water lies a fascinating world. A universe of tiny particles moving in a delicate ballet. Water molecules are tiny magnets, constantly attracting each other. This magnetic attraction is due to the polar nature of water molecules, where the oxygen end is slightly negative, and the hydrogen end is slightly positive. This attraction is called cohesion, and it's the driving force behind surface tension. Cohesion allows water molecules to stick together, creating a strong bond that holds the droplet intact. Within the droplet, these tiny magnets pull on each other equally in all directions, creating a harmonious balance. This balance ensures that the droplet maintains its shape and doesn't collapse under its own weight. They link arms in a special dance, forming what we call hydrogen bonds. These bonds are relatively weak individually, but collectively they create a strong network that holds the water molecules together. Imagine a network of tiny hands holding onto each other, creating a tight-knit community. This community of molecules is what gives water its unique properties, such as its high surface tension and ability to form droplets. However, at the surface the dance changes. The molecules at the surface experience a different environment compared to those inside the droplet. The molecules at the edge have no upward pulling neighbors. This lack of upward attraction causes them to pull more strongly on their sideways neighbors. They cling tighter to their side buddies, forming a taut, invisible film. This film is what we observe as surface tension, a force that allows the droplet to maintain its shape and resist external pressures. This film is what gives water droplets their incredible strength and allows them to resist external forces. It's why water droplets can maintain their shape even when subjected to external forces like wind or gravity. Remember the raindrop clinging to the leaf? This is a perfect example of surface tension in action. It's the surface tension that makes this delicate balancing act possible. The water molecules at the surface create a strong enough bond to hold the droplet together, even against the pull of gravity. Now let's investigate why this microscopic dance favors the sphere above all other shapes. The spherical shape minimizes the surface area, allowing the droplet to maintain the most stable and energy-efficient form. Nature's efficiency expert. Why a sphere? Nature loves efficiency, and the sphere is the epitome of this principle. Think of a soap bubble. It naturally forms a sphere because this shape allows it to enclose the most air within the least amount of soapy film. The same principle applies to water droplets. A sphere has the smallest surface area for a given volume compared to any other shape. This means that a spherical water droplet can hold the most water molecules together with the least amount of surface tension. It's nature's way of conserving energy. Every other shape, whether a cube, a pyramid, or even a flat sheet, would require more surface tension to hold the same amount of water, making them less stable and less efficient. Gravity's tug. The droplets fall from grace. So far, we've imagined our water droplets suspended in midair, perfect spheres sculpted by the invisible hand of surface tension. But what happens when gravity enters the equation? As a droplet grows larger, clinging to a leaf or a window pane, the pull of gravity becomes too strong to resist. The once perfect sphere begins to distort, stretching downwards into the familiar teardrop shape. This is a delicate tug-of-war between surface tension, striving to maintain the droplet's spherical form, and gravity, relentlessly pulling it downwards. Eventually, gravity wins. The surface tension can no longer hold, and the droplet breaks free, falling towards the earth. But even in its descent, surface tension continues to play its part. Sticky situations. When water meets the world. Water droplets don't exist in a vacuum. They interact with the world around them, encountering surfaces of all shapes and sizes. This is where adhesion comes into play. Adhesion is the force that attracts water molecules to other substances. Remember the hydrogen bonds we talked about? They can form between water molecules and other materials too. This interplay between cohesion and adhesion determines how a water droplet behaves on different surfaces. On a hydrophobic surface, like wax paper, water molecules are more attracted to each other than to the surface. This causes the droplet to bead up, maintaining a near spherical shape. Conversely, on a hydrophilic surface, like glass, water molecules are more attracted to the surface, causing the droplet to spread out and wet the surface. Surface tension in action, from soap bubbles to space. Surface tension isn't just a scientific curiosity, it plays a vital role in our everyday lives and beyond. Think of washing dishes. The soap breaks down the surface tension of greasy water, allowing it to spread and clean more effectively. Without surface tension, bubbles wouldn't exist, depriving us of the simple joy of blowing shimmering spheres into the air. Surface tension even plays a crucial role in nature. Water striders, those insects that seem to magically walk on water, rely on surface tension to stay afloat. In the vast expanse of space where gravity is negligible, water droplets truly embrace their spherical nature, floating freely as perfect miniature planets. Beyond H2O, a world of liquid personalities. Water, with its remarkable surface tension, is just one player in the diverse world of liquids. Each liquid has its own unique personality, dictated by the strength of the bonds between its molecules. Mercury, for instance, has much stronger cohesive forces than water, resulting in incredibly high surface tension. That's why mercury forms beads that roll around like tiny ball bearings. On the other hand, oil has weaker cohesive forces than water, leading to lower surface tension and explaining why oil spreads out on water instead of forming droplets. This difference in surface tension has significant implications in various fields, from industrial processes to environmental science. The shape of life. A final word on water's tiny miracle. The next time you see a water droplet, take a moment to appreciate the intricate forces at play. These tiny droplets are not just simple beads of water, they are a testament to the complex interactions that govern our natural world. It's a delicate dance between cohesion, adhesion, and gravity, shaping this tiny world into a perfect sphere. Cohesion keeps the molecules together, while adhesion allows them to interact with other surfaces. Gravity, of course, pulls them down, creating that familiar droplet shape. Surface tension, that invisible skin, is essential for life as we know it. This phenomenon allows water to form droplets and enables insects like water striders to walk on water. It's a force that plays a crucial role in various natural processes. It allows plants to draw water up their roots, defying gravity through capillary action. This process is vital for the survival of plants, which in turn support countless other forms of life. Surface tension also shapes the clouds that bring us rain, contributing to the water cycle that sustains life on Earth. These clouds are formed by countless tiny droplets coming together, each playing its part in a larger system, and even influences the behavior of cells in our own bodies. Water is essential for cellular functions, from nutrient transport to waste removal. The properties of water droplets are mirrored in the microscopic world within us. The humble water droplet, a miniature marvel of nature, reminds us that the most profound wonders often lie hidden in plain sight. These droplets are not just a part of our environment, They are a reflection of the intricate balance that sustains life. It's a testament to the elegance and efficiency of the natural world, where even the smallest structures play a vital role in the grand tapestry of life. From the tiniest droplet to the vast oceans, water is a unifying element that connects all living things, where even the smallest structures play a vital role in the grand tapestry of life. Dewdrops on flowers provide essential hydration for insects, and the morning dew nourishes the soil, supporting plant growth. So, the next time you encounter a raindrop, a dewdrop, or even a teardrop, take a moment to marvel at the science and beauty behind it. These droplets are more than just water, they are a symbol of the interconnectedness of all life. Remember the fascinating science that governs its shape. The forces of cohesion, adhesion, and gravity work together to create these perfect spheres, each one a tiny miracle. And appreciate the beauty of this tiny perfect sphere. In every droplet, there is a story of nature's ingenuity and the delicate balance that sustains life on our planet.